to run that setup in the next module. You can access HDFS programmatically or with the Hadoop command, which for HDFS shares some of the command names that the Linux file system uses. So to list the files in HDFS, I can run Hadoop fs, which is the prefix for HDFS commands, and -ls to list the contents of a directory. HDFS is a hierarchical file system with directories that can contain other directories and files, just like Windows, and I can list the contents of the root directory with the /. HDFS uses // in directory paths whether you're running on Windows or Linux. To store a file in HDFS, use the put command to copy from a local file, which takes the source and target file paths. In the temp folder, I have a file I'll be using, which is a large CSV file. I run Hadoop fs-put /temp/postcodes.csv to /input/postcodes.csv to copy it to HDFS. The temp path is the full source path on the local file system, and the target path is the full path in Hadoop. This is a fully qualified path in HDFS, so it will copy the file into the input directory in the HDFS root, and the command will fail if the directory doesn't exist. When the put completes, I can list the files with Hadoop fsls/input, and I see my file is in there, and it's about 660 megabytes. The get command fetches files out of HDFS, so Hadoop fs-get input postcodes.csv temp p2.csv will copy the file from HDFS back into the temp directory on the local file system. And HDFS also supports the tail command, which outputs the last kilobyte of data in the file. So with Hadoop fs-tail input postcodes.csv, I see the last few lines, and I can compare that to the local file by running tail-n1 temp p2.csv, and we can see that the data in the last line is the same on HDFS and in the local file system. This container is actually running as the Hadoop master. Hadoop is a Java system, and I can run JPS to show me all the Java processes which are running. I have the Yarn resource manager and HDFS name node services running here. This container isn't running as a data node, so it doesn't have any of the file blocks for my CSV file stored locally. When I run get or tail, the data comes from the worker nodes, which are the other 4 containers, each running the data node service. With the default HDFS block size and replication factor, my 660 megabyte file gets split into 5 blocks, and each block gets replicated 3 times. The HDFS file system check command checks the file system for a given path, and that confirms the number of blocks and the replication factor for my CSV file. It would also show me if any replicas were missing or corrupt. In another session, I can connect to one of the worker nodes using docker exec. Running JPS here shows me that the Yarn node manager and HDFS data node services are running, so this is a storage and compute worker node. This node will contain some of the file blocks for my CSV file, and I can use the ordinary file system ls command to list the contents of the HDFS data directory, which is this improbably deep path starting at HDFS/data. The root directory is where HDFS is configured to store blocks on the file system, and you'd never normally check the contents on a worker node. But just to demonstrate, I can see we've got 3 blocks on this data node, which are 130 odd megabytes each, and each one has a metadata file. Because of the way Hadoop replicates data, I can stop this node, which is effectively like turning the machine off, and that means I now have 3 workers in my cluster. Back on the master node, I can run HDFS file system check again, and see that I now have 3 missing replicas, which means Hadoop is aware that that data node has gone. But I can run Hadoop fs-tail again, and still see the file contents, because HDFS gracefully copes with the loss of that data node. That's actually all we need to know about HDFS to get started with Hadoop, so next we'll move on to the compute layer.